1.1.1. We are given 2x minus 4 times x minus 1 is equal to 0. So here we can see that the product is equal to 0. So there is no need to multiply out the brackets. So if the product is equal to 0, that means 2x minus 4 is equal to 0, or x minus 1 is equal to 0. And then from here we can transpose 4, then divide by 2. So we are going to have x is equal to 4 over 2 is the same as 2, or x transpose 1 is equal to 0 plus 1, which will be 1. And then this question is only 2 marks. Question number 1.1.2. So 1.1.2. So we are given 2x squared minus 3 into x plus 2 is equal to 4. So here in this question, we are told to round off our answer to 2 decimal places. So that means we need to use quadratic formula. But before we use quadratic formula, we need to make sure that our equation is written in a standard form, in a form of ax squared plus bx plus c. Now, we need to remove these brackets here. We are going to have 2x squared minus 3x minus 6. And then if I transpose 4, I will have minus 4. This is equal to 0. And then add the like terms. Minus 4 minus 6, this will be minus 10. So I am going to have 2x squared minus 3x minus 10 is equal to 0. And then from here, I can see my value of a. My value of a is positive 2. My value of b is negative 3. My value of c is negative 10. And then quadratic formula for grade 12, it is provided in the information sheet. But for grade 11, you need to know all the formulas by heart. So we are going to have x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. And then the next step is substitution. So this will be x is equal to minus, we said our value of b is negative 3, and then we have plus or minus square root of, now square root of minus 3 all squared minus 4 into our a is positive 2, our c is negative 10 all over 2 multiplied by our a again, it is positive 2. So we are going to have x is equal to, or x is equal to. Now, if I use negative sign, I am getting negative 1, 6, 1. And then if I use a positive sign, I am getting 3, 1, 1. So these are my values of x. And then let's move to 1.1.3. 1.1.3, we are given x squared plus 4x minus 21 is less or equal to 0. So here I need to factorize. So we are dealing with inequality. So less than 0 means your function is below the x-axis, or it is negative. Now, so we are looking for factors of 21 that I will subtract and get 4. So we have x. Factors of 21 that I will subtract and get 4, it will be 7 and 3. So the signs are different. So the bigger number will go with the middle term. So we have plus and then we have minus. So this is less or equal to 0. Now, our critical values here are x is equal to -7 or x is equal to positive 3. This is not your solution as yet. For now, we have critical values. Now, I can conclude using a number line, or I can draw a parabola that is concave up. The reason why my parabola is concave up, because the number in front of x squared here is positive 1. The value of a is positive. So if I draw a parabola that is concave up, here is my parabola concave up, and then I write my critical values here, starting with a smaller number, which is -7, and then it will be followed by 3. Now, I am looking for values of x where this curve is below, it is below this line. So it is below the x-axis. So now I am going to highlight my graph below. So here is my graph below the x-axis. So I can see that I have highlighted from -7 to 3. So this one is happening in between. So the final answer here will be x. You just write your x. It must be in between because I have highlighted in between as well. But because this one, the inequality that is given, it also include -7 and 3. So your solution is from -7 to 3. This can be written as x is an element because -7 is included. So you use a square bracket. So it -7. 3 is also included to 3. So that is your solution. So x is from -7 to 3. Then we are done with this question. 1.1.4. Let's see 1.1.4. 1.1.4. We are given negative root x minus 1 is equal to 3 minus 2x. So here we can see that we have a square root. So to get rid of this square root, we need to square on both sides. So if I square on both sides, I'm going to have negative root x minus 1 all squared is equal to 3 minus 2x all squared. And then from here, if the exponent is an even number, so this negative will always go away, because negative times negative, it is always positive. And then squared will reverse the square root. So I will remain with positive 1 multiplied by x minus 1 is equal to, now, if I square this, remember squared means the bracket exactly as it is repeated twice. So it will be 9 minus 6x minus 6x, which will be minus 12x, and then plus 4x squared. And then I can see that the highest exponent is 2. So I need to write my equation in a standard form, in a form of ax squared plus bx plus c. So this will be 4x squared, and then negative 12x minus x, it will be minus 13x. And then 10, not 10, but 9 plus 1 will be 10. So this is plus 10 is equal to 0. Now I need to factorize this. So usually if the coefficient of x squared is not 1, so learners they struggle to factorize this, but you can always use quadratic here. So now look at this. So if you use quadratic formula, you will get x is equal to 5 over 4, or x is equal to 2. Now you can transpose 2, so you will have x minus 2 is equal to 0. So you just put x here, you just put x minus 2. With this one, because this one is a fraction, we need to multiply everything by 4 first. So you'll have 4x is equal to 5, and then you transpose this 5, and then you will have 4x minus 5 is equal to 0. And then here you just put 4x minus 5, and then you have factorized. Now, and then from here, we can solve for x. So our x is equal to 5 over 4, or our x is equal to positive 2. So we need to check if these two answers are valid or not. Now, I will take this 5 over 4. Yeah, 5 over 4. I will take this 5 over 4 and substitute where there is x. So if I substitute 5 over 4 where there is x, I am getting negative 1 over 2. But now if I take this 5 over 4 and substitute it in my right hand side where there is x again, I am getting positive 1 over 2. And the negative 1 over 2 is not the same as positive 1 over 2. Since the left hand side is not equal to right hand side, when I substitute 5 over 4, that means 5 over 4 is not applicable. This one is not applicable. But now if I substitute 2 on my left, I get negative 1. On my right, I also get negative 1. So that means the only solution is x is equal to 2. This is my only solution. So x is equal to 2. So now let's move to 1.2. 1.2, we are required to solve for x and y simultaneously. So we are given two equations. Equation 1 is 2x is equal to 1 minus y. Okay, this is our equation number 1. We are also given equation number 2 as xy minus x squared plus y squared is equal to 5. This is equation number 2. Now, from equation number 1, we can make x or y subjects of the formula. Because the coefficient of y is 1 or negative 1, it is very easy to make y subjects of the formula. So with equation number 1, I am going to take y to the left so that it becomes positive, and then I will take my 2x to the right so that y is the subject of the formula. Now I am going to have y is equal to 1 minus 2x, and then I will call this equation number 3. Now I am going to substitute equation number 3. I am going to substitute equation number 3 into equation number 2. So sub 3 into 2. Now that means where I see y, when I see y, I am going to put 1, minus 2x. So I am going to have x, and then where I see y, I replace that y with 1 minus 2x minus x squared plus, and then there is y again. So instead of y, I am putting 1 minus 2x all squared. This is equal to 5. And then from here, I am going to remove the brackets. So now I am going to have x multiplied by 1, which is x multiplied by negative 2x, which will be negative 2x squared, and then minus x squared. And then these, I can see that they squared. So the bracket, exactly as it is repeated twice. So I am going to have 1 minus 2x multiplied by 1 minus 2x. Now 1 multiplied by 1 is the same as we have 1, and then 1 multiplied by negative 2x, it will be negative 2x, and then negative 2x multiplied by 1, it is negative 2x, and then if you add the like terms, I will have negative 4x, and then negative 2x multiplied by negative 2x, it will be plus 4x squared. This is equal to 5. Now I am going to write my equation in a standard form. I will add all the like terms. Okay, here I have 4x squared minus 2x squared, which will be 2x minus x squared, which will be x squared. So I have x squared, and then negative 4x plus x, it will be minus 3x. So I have minus 3x, and then I also have 1. If I transpose 5, it will be 1 minus 5. 1 minus 5, it will be negative 4. This is equal to 0. And then from here I can factorize. So I am looking for factors of 4 that I will subtract and get 3. So the factors of 4 that I will subtract and get 3, that will be 4 and 1. And then this is minus, this is plus, this is equal to 0. Now my x is equal to positive 4, or x is equal to negative 1. So we have found the values of x. Now I need to find the values of y. Okay, we take these x values that we got here, we substitute in equation number 3. So if I substitute in equation number 3, I am going to have y is equal to 1 minus 2 multiplied by 4, which would be y is equal to negative 7. Or y is equal to 2 multiplied by, y is equal to 1 minus 2 multiplied by negative 1. This will be y is equal to 3. So now I have solved for x and y simultaneously. So I am done with 1.2. Okay, now let's move to 1.3. Okay, 1.3, let's see what is it that we have and what is it that is required. I'm given 2 equations. The first equation that is given, we are given f of x is equal to x squared plus 3x. Equation number 2 that is given, we are given 2x minus, and then we have t of x to the exponent 1 over 2. Okay, so it's t of x to the exponent 1 over 2. It is equal to 0. And now the question is, for which values of k will, and then now we are given f of minus x plus 2 of or t of 2k over 4 is equal to 0, will have equal roots. Now, before I even start with equal roots, I need to set up this equation here. So fortunate enough, I do have the equation of f of x. So where there is x, we will replace that x with negative x. But now I do not have the equation of t of x, where I will replace our x with 2k. But from equation number 2 here, that is given, I can make a t of x subject of the formula. So if I make t of x subject of the formula, I'm going to have, it will be 2x is equal to, now, t of x to the exponent 1 over 2. 1 over 2 is the same as square root. So I can remove the exponent of 1 over 2 by multiplying it with the reciprocal. So the reciprocal here is 2 over 1. So it is the same as squaring on both sides. And then here I will also square. Now, this will be 2x all squared. It is the same as 4x squared. And then now this and that reverse each other. So this is equal to t of x. Now I do have the equation of t of x. I do have the equation of f of x. I can now set up the equation that is in question. Okay, so here we are going to have so here we are going to have our f of negative x will be negative x all squared plus 3 multiplied by negative x plus now t of 2k over 4 will be so where there is x, we just put 2k, will be will be 4, and then where there is x, we just put 2k, so it will be 2k all squared all over 4. This is equal to what? This is equal to 0. Okay, so this will give us x squared minus 3x. 4 and 4 cancel, and then we have plus 4k squared is equal to 0. Now, so for roots to be equal, so this equation must have equal roots, remember. So for roots to be equal, b squared minus 4ac must be equal to 0. This is your discriminant. Now, our b is negative 3 all squared minus 4. Our a is 1, and then our c is 4k. This 4k squared, this must be equal to 0. Now, we have 9 is equal to, not equal to, but we have 9 minus 16k squared is equal to 0. And then here we can factorize the difference of two squares. 9 is a perfect square. 16 is a perfect square. The exponent of k can be divided by 2. So we have a difference of two squares. So factorize the difference of two squares. So we are going to have 3, and then plus 4k and then minus 4k is equal to 0. Therefore, our k is equal to negative 3 over 4, or our k is equal to positive 3 over 4. And then we have solved for k, for which the roots of that equation will be equal. Now, let's move to the next paper, another 24 marks. 1.1, we are given 7 minus x multiplied by 10 plus x is equal to 0. Again, we can see that the product, this is the product because we are multiplying, the product is equal to 0. So if the product is equal to 0, there's no need to multiply out the bracket. That means 7 minus x is equal to 0, or 10 plus x is equal to 0. And then from here we can solve for x, transpose this x so that it becomes positive. So you are going to have 7 is equal to x, or transpose 10, so x is equal to minus 10. We have solved for x. X is equal to 7, or x is equal to negative 10, and then you get that 2 marks. 1.1.2, 1.1.2. We are given 3x into 2x plus 1. This is equal to what? This is equal to 1. So now if you check 1.1.2, we are told to round off our answer to 2 decimal places. So that means we need to use a quadratic formula, or we can even complete the square. But quadratic is the easiest. So before we use the quadratic formula, we need to make sure that our equation is written in a standard form. Ax squared plus bx plus c is equal to 0. So we are going to multiply out the brackets. So we are going to have 6x squared plus 3x. If we transpose 1, it will be negative 1. This is equal to 0. And then from here, we can see our value of a, we can see our value of b, we can also see our value of c. So our a is positive 6, our b is positive 3, and then our c is negative 1. And then from here, we can write our quadratic formula. For grade 11s, remember, it is not provided, but for grade 12, they do have the formula in their information sheet. So we have x is equal to minus b plus or minus square root of b squared minus 4ac all divided by 2a. And then from here, we are going to have x is equal to minus, and then what is b? B is positive 3 plus or minus square root of positive 3 all squared minus 4. Our a is 6, and then our c is minus 1 all divided by 2 multiplied by positive 6. And then from here, we'll get 2 values of x. So if we use negative, our x is negative 0.73, or our x is 0.23. So these are values of x rounded off to 2 decimal places. And then let's move to 1.1.3, which is an inequality. Okay. 1.1.3, we are given 6x squared plus 7x plus 2. This is greater or equal to, this is greater or equal to 0. Remember, greater than 0 means above. So this is above or equal to 0. So above or positive. Now, again, we need to factorize this. Usually learners will struggle to factorize when the coefficient of x squared is not 1. So in this case, our coefficient of x squared is positive 6. So now what you can do, you can open two brackets here, okay? Let's have two brackets first. This is greater or equal to, this is greater or equal to 0. And then if you substitute this in your quadratic formula, so you will get x is equal to negative 2 over 3. You will also get x is equal to negative 1 over, you will also get x is equal to negative 1 over 2. Now here you can multiply everything by 3. So this will be 3x is equal to negative 2, and then you transpose 2. So if you transpose 2, you are going to have 3x plus 2. So here you have your 3x plus 2. And then with this one as well, you can multiply everything by positive 2. So you have 2x is equal to minus 1. And then if you transpose that one, you are going to have 2x. And then plus what? Plus 1. Now we have factorized. Okay. And then that means our critical values here are, you will have x is equal to minus 2 over 3, or you will have x is equal to minus 1 over 2. These are your critical values, not your solution as yet. Now, we can draw, or let me use a number line. So if we use a number line, because on the first one, I used parabola. So if you use a number line, so here, you write your critical values, starting with the smaller one. So it will be minus 2 over 3, and then minus 1 over 2. And then now, the number in front of x squared is positive. So if the coefficient of x squared is positive, we start with positive, negative, then positive. So if I were to draw a graph here, so it was going to be something like this. So here is your parabola that is concave up. And then now, we are looking for positive above or above. Greater than 0 positive. Where is positive? So positive here is positive. It is also your above. Positive and above is one and the same thing. So you can see that we have highlighted from this point, and then we went to the left. We also highlighted from this point, which is minus 1 over 2, we went to the right. So your solution for this one, since you have a separate region, your answer must have an or. So it or. So you will say x, you copy the arrow, is less or equal to minus 2 over 3, or x, you copy the arrow, is greater or equal to minus 1 over 2. That is your solution. Now, let's move to 1.1.4. Okay. 1.1.4. Okay. 1.1.4. Here we are given there is a square root, and then under the square root there is another square root, and then we have 2x here, and then plus x is equal to 2. Now, since we have a square root, number one, we need to get rid of this square root. So we need to square on both sides. Now, if I square on both sides, I'm going to remain with the square root of 2x plus x, because if I square on both sides, this square root will go away. And then what is 2 squared? Because I squared on both sides, 2 squared will be positive 4. We can see that we still have a square root here. So that means we still need to square on both sides. But now, before you even square on both sides, make sure that anything that is not under the square root or anything that is not attached to the square root is isolated. So now that means we need to transpose this x so that we have 2x is equal to 4 minus x. Now you can see that there is nothing that is outside the square root. There is nothing that is not attached to the square root. We can now square on both sides. So square on both sides, squared. So even here we square. Now if we square here, squared will remove the square root. So we will remain with 2x is equal to, now 4 minus x all squared. It will be 16 minus 8x plus x squared. So remember, squared means the bracket exactly as it is. It is repeated twice. Now, from here, we can see that the highest exponent is 2. So we need to write our equation in a standard form. So we are going to transpose 2x, take it to the right. So if we take it to the right, we are going to have x squared minus 8x, minus 8x minus 2x, and then plus 16 is equal to 0, which will give us x squared minus 10x plus 16 is equal to 0. And then here we can look for factors of 16 that we can add and get 10. So this is equal to 0. So factors of 16 that can be added to get 10 is 8 and 2. Because 8 times 2 is 16, but 8 plus 2 is 10. So 16 is positive. So the signs are the same as the Meakley number. So it minus and minus. So that means x is equal to 8 or x is equal to positive 2. So with this one, you need to check if your answers are both valid or not. So now if we substitute 8 where there is x, if we put 8 here, we are going to have the square root of 16, which is 4. 4 plus 8 will give us 12, and then the square root of 12 is not equal to 2. So that means 8 is not your solution. So this one is not applicable. Now, if you put 2 where there is x, you are going to have the square root of 4 under that big root, and then the square root of 4 is the same as 2, and then 2 plus 2 that you are going to put in this x as well. 2 plus 2 is 4, and the square root of 4 is 2. So therefore x is equal to 2 only. So this is the only solution. So x is equal to 2. (1.2) we are required to solve for x and y simultaneously. So we are given two equations, negative 2y plus x is equal to 4. We are also given x squared plus xy minus 2y squared is equal to 0. Now we have our equation number 1. We also have our equation number 2. Now we will notice that it is very easy to make x subject of the formula from equation 1 because the coefficient of x is positive 1. Now, we are going to transpose negative 2y to create equation number 3. So our equation number 3 will be x is equal to 4 plus 2y. So this is our equation number 3. Now, where I see x, I am going to replace that x with 4 plus 2y. Now, we are going to sub 3 into 2. Now, here is x, so I am replacing that x with 4 plus 2y all squared. Plus, here is another x, so I am replacing that x with what? With 4 plus 2y. But there is also another y here, so I prefer to write it in front. This is minus 2y squared. It is equal to, and then from here, we will remove all the brackets. Now, so remember, squared means the bracket, exactly as it is repeated twice. So if I multiply this bracket out, I will have 4 multiplied by 4, which is the same as 16. And then I will have 4 multiplied by 2y, which is the same as 8y. And then I will also have 2y multiplied by 4, which is another 8y. 8y plus 8y, it will be 16y. And then 2y multiplied by 2y will be plus 4y squared. And then y multiplied by 4, it will be plus 4y again. And then plus 2y squared minus 2y squared. This is equal to 0. Now, I am going to add all the like terms. 4y squared plus 2y squared minus 2y squared, it will remain as 4y squared because these two will cancel out. So we have 4y squared here. So we have 4y squared. And then we have 16y plus 4y, which is positive 20y. And then plus 16, this is equal to 0. Now, we can see that 4 is a common factor here. We can divide everything by 4. So if I divide everything by 4, I will remain with y squared plus 5y plus 4. This is equal to 0. And then we can factorize this. We are looking for factors of 4 that we can add and get 5. It is 4 and 1. So we have y, we have 4 and 1. So the signs are the same because 4 is positive. They are the same with the middle term, so it plus and plus. This is equal to 0. And then from here, we can see that our y is equal to negative 4, or our y is equal to negative 1. Now, we have found the values of y. Now, we need to find the values of x. Now, we take these values and we substitute in equation number 3. Now, if we substitute in equation number 3, we are going to have x is equal to 4 plus 2 multiplied by negative 4, which will be negative 4. Or x is equal to 4 plus 2 multiplied by negative 1, which will be positive 2. So the values of x are negative 4 and negative 2, and the values of y are negative 4 and negative 1. So now let's move to 1.3. Okay, let me see 1.3. 1.3, we are given 4 to the exponent m is equal to p into 2 to the exponent 2m minus 1, and then plus what? Plus p. So now we want to prove that m is equal to. So that means first thing first, I need to isolate m. So anything that has m, I need to put it to one side so that I'll be able to solve for m. Now, if I try to do that, remember 4 to the exponent m is the same as 2 to the exponent 2m, and then transpose this so that everything that has m is on one side. So I will have minus p multiplied by 2 to the exponent 2m. So if I split this, it is the same as multiplied by 2 to the exponent minus 1. So this is equal to p. Now here, on my left, I have two terms, 1, 2. So if I have two terms, I can factorize. There is a common factor. I can see that 2 to the exponent 2m is a common factor. It appears in both terms. Now here I will remain with 1 minus, this will be p multiplied by 2 to the exponent minus 1. So this is equal to p. Now I can divide on both sides by this bracket. Let me sort it first. So this is the same as 2 to the exponent 2m into, now remember, 2 to the exponent minus 1 is the same as 1 over 2. So I can write this as p over what? As p over 2 is equal to p. So we have 2 to the exponent 2m is equal to, if I sort this out again, because here I am subtracting fractions, so this will be, okay, so 1 can be written as 2 over 2, so I will have 2, and then I will have 2 minus p. This is equal to p. And then now I can multiply on both sides by a reciprocal of this to get rid of this. I can multiply on both sides by reciprocal of this. So I will have 2 to the exponent 2m is equal to, now this will be p. If I multiply by reciprocal, it will be 2 over 2 minus p. Okay, so now I have 2 to the exponent 2m is equal to 2p over 2 minus p. Now I can see that m is an exponent, so I need to introduce logs. So here I will have 2m is equal to log. My base is 2 of a number. The number is 2p over 2 minus p. Now I am looking for m. So I am going to divide on both sides by 2. So if I divide by 2 on both sides, I will have m is equal to 1 over 2. Remember, dividing by 2 and multiplying by 1 over 2 is one and the same thing. Log base 2, and then of a number, the number is 2p, 2 minus p. And then I have proved what was required to prove. So yes, our m is equal to 1 over 2 log base 2 of a number, which is 2p over 2 minus p. And then we are done with this paper. So I am moving to the next one. So in this video, I will make only 3 papers, or I will go through 3 papers, and then maybe I will make another video for another 3 papers again. And then I will move into 1.1. here we are given 2k is equal to x minus 5, x minus k. And we are required to find the value of k if x is equal to 2. Now that means where there is x, we are going to put 2. Now, if we put 2 where there is x, we are going to have, okay, here is our 1.1.1. So where there is x, we put 2. We are going to have 2k is equal to, and then now where there is x, we just put 2. 2 minus 5 into 2 minus k. And then from here, we can solve for k. So now, we are going to have 2k is equal to, now 2 minus 5 is the same as negative 3 into 2 minus k. And then from here, we have 2k is equal to, and then multiply the brackets out. So we are going to have negative 3 multiplied by 2, which will be negative 6. Negative 3 multiplied by negative k, which will be positive 3k. And then now we group the like terms. So I'm going to take 3k to my left. So I'm going to have 2k minus 3k is equal to negative 6. So now what is 2k minus 3k? It is negative k is equal to negative 6. So therefore, my k will be positive 6 if I divide it throughout by negative 1. And then that is my 1.1.1. 1.1.2. Now, we are required to solve for x if k is equal to 2. So now 1.1.2. So that means where there is k now, I'm going to put 2. So I'm going to have 2 multiplied by 2, because k is now 2, is equal to x minus 5 into x minus, what is k? K is 2. And then from this, I need to solve for x. Now, this is the same as x minus 5 into x minus 2. Now, what is 2 times 2? 2 times 2 is the same as 4. Now, we can see here that we have the product. Unfortunately, our product is not equal to 0. So if the product is not equal to 0, that means I still need to have removed the brackets. So I will multiply the bracket out. So I'm going to have x multiplied by x, which will be x squared. X multiplied by negative 2, which will be negative 2x. And then negative 5 multiplied by x will be minus 5x. And then negative 5 multiplied by negative 2, this will be positive 10. And then if I transpose 4, it will be minus 4 is equal to 0. And then from here, I am going to, from here I'm going to add to the like terms. So I will have x squared minus 7x, and then 10 minus 4, it is plus 6. This is equal to 0. Now, 6 is positive, so we are adding. I'm looking for factors of 6 that I will add and get 7. So it is 6 and 1. So I will have x and x, 6 and 1. So the signs are the same with the middle term, so it's minus and minus. So we have, therefore, x is equal to 6, or x is equal to 1. So x is equal to 6, or x is equal to 1. And then we are done with 1.1 and 1.2. Let's move to 1.2.1. Now, 1.2.1. Now, 1.2.1, we can see that we are required to correct our answer to 2 decimal places. So if we are required to correct to 2 decimal places, that means we need to write our equation in a standard form and then use a quadratic formula. So standard form will be 2x squared minus 8x and then plus 3. This is equal to 0. Now our equation is written in the form of ax squared plus bx plus c is equal to 0. Now from here we can see our a is positive 2, our b is negative 8, our c is positive 3, and then we write our formula. So we have x is equal to minus b plus or minus square root of b squared minus 4ac all divided by 2a. Now substitution, so x is equal to minus our b is negative 8, and then plus or minus we have root, and then we have our b, which is negative 8 all squared minus 4. What is a? Our a is 2. What is 8? Our a what is c? Our c is 3 all divided by 2 multiplied by what is our a? Our a again is 2. Now x is equal to, or x is equal to, now we are required to round off to 2 decimal places, so we are going to have 3,58 as well as 0,42. So these are our values of x. So it's 0,42 and 3,58. Okay, now let's move to 1.2.2. Okay, let's see 1.2.2. Okay. (1.2.2). We are given a square root, and then under the square root we have 2 into x plus 10, and then just outside the square root we have minus 10 is equal to x minus 12. So here we can see that we have a root. So if we have this root, we need to remove it by squaring on both sides, but we cannot square on both sides while we still have this 10, which is outside the square root and is not attached to a square root. So 10 must be transposed. So here, before we even square on both sides, we need to isolate. So we have 2 into, and this is x plus 10 is equal to, now if I transpose 10, this will be x, and then minus 12 plus 10, it will be minus 2. And then now I can square on both sides. So squaring on both sides, squared, all this squared. So if I square on both sides, I'm going to have this and that removed. So I will remain with 2. X plus 10 is equal to, and then if I square this, it will be x squared minus 4x, and then plus 4. Remove the bracket, so it 2x plus 20 is equal to x squared minus 4x, and then plus 4. Now again, I can see that the highest exponent is 2. My equation needs to be written in the form of ax squared plus bx plus c. So I am going to take everything to my right and then add the like terms. So if I do that, I will have x squared. Now, what is negative 4x minus 2x? It will be negative 6x. And then 4 minus 20, it will be minus 16. This is equal to 0. Now, I am looking for factors of 16 that I will subtract and get 6. So we have x, it will be 8 and 2, because 8 multiplied by 2 is 16, but 8 minus 2 is 6. Remember, if this term is negative, we subtract, and then if it is positive, we add. Now, we can see that the middle term is negative, so the bigger number will take a negative, and then here we have a plus, because signs are different since our c is negative. And then now from here, we can see that our x is equal to positive 8, or our x is equal to negative 2. Now we need to check. So if we take these values, if we take this 8 here and substitute where there is x, and then we will substitute on our left hand side as well as our right hand side, we can see that 8 will give us the answer. Okay, let's check. Okay, you can just check. So we are going to have square root of 2, and then we have 8 plus 10. Okay, and then minus what? Minus 10. So 8 plus 10 is the same as 18, and then if you multiply that by 2, it is 36, and then the square root of 36 is 6, and then what is 6 minus 10? And then if you have 6 minus 10, you will always get negative 4. And then now you need to take this 8 and substitute again on your right hand side. You are going to have 8 minus 12, which is also minus 4. So that means this one is correct. And then if you substitute negative 2, if we substitute negative 2, you are going to have minus 2 plus 10, which will be positive 8. Positive 8 multiplied by 2 is 16. The square root of 16 is 4. But now if I put negative 2 on my right hand side, I'll get negative 14. So negative 2 is not applicable. The only answer is x is equal to 8. Let me move to the next one. 1.2.3 inequality. Okay, let me put this here. 1.2.3. 1.2.3, we are given 3 to the exponent x. 3 to the exponent x into x minus 5 is less than 0. So this one is a little bit different. So this one you can treat it as functions. You have your f of x, and then you have your g of x. So you have your f of x multiplied by g of x. It must be less than 0. That means if one function is positive, one must be negative. And we can see that this one is an exponential function. So 3 to the exponent x, if I were to draw a graph, you will notice that 3 to the exponent x is positive for all values of x. So we know that 3 to the exponent x is greater than 0 for x is an element of all real numbers. So the only thing here that can be negative is this one, is the straight line. So we will say therefore x minus 5 must be less than 0, because it is the only thing that can be negative, and then that means x must be less than 5. So if x is less than 5, and then we will have f of x multiplied by g of x less than 0. So the answer here is x is less than 5, because this part, which is 3 to the exponent x, is positive for x is an element of all real numbers. And then let me move to the next question. which is 1.3 simultaneous equation. All right, now 1.3, we are required to solve for x and y simultaneously. Okay, we are given equation number 1 as square root of 3 to the exponent x multiplied by 9 to the exponent y is equal to 27. And then we are given our equation, okay, this is 1. We are given our equation number 2 as x plus 4y squared is equal to 6. Now, you need to remember how to get rid of this root. So to get rid of root, if you have x, or if you have root x, and then if you have p and q here, this can be written as x, and then inside p over outside p over q. So that means even here, we can write this as 3, and then inside here we have x over 2, because if you have a square root, we know there's 2 there. And then we can say multiply by, we can always change this base and write it as a prime number. So 9 is the same as 3 squared. So it is 3 to the exponent 2y. This is equal to 3 to the exponent 3, because 27 is the same as 3 to the exponent 3. Now, we can see here that the bases are the same, and we are multiplying. We can just keep one base and add to the exponents. So we are going to have 3 and then x over 2 plus 2y is equal to 3 to the exponent 3. Now again, we can see that the bases are the same, so we can just drop the bases again. If we drop the bases, we are going to have x over 2 plus 2y is equal to 3, because if the bases are the same, therefore exponents are equal. Then we can multiply everything by 2. If I multiply everything by 2, I'm going to have x plus 4y is equal to 6. I have multiplied everything by 2. So multiply everything by 2. Even here, multiply everything by 2. And then from here, we can transpose 4y. So we are going to have x is equal to 6, and then minus 4y. And we can call this our equation number 3. So we do have our equation number 1, we have our equation number 2. At least now we have our x as the subjects of the formula. Now we can sub equation 3 into 2. Now where we see x, we are going to replace x with 6 minus 4y. Now we are going to have 6 minus 4y plus 4y squared is equal to 6. Now if we transpose 6, we are going to have 6 minus 6, which will be 0. So our equation will be now 4y squared minus 4y is equal to 0. Here we can see that we can take out the common factor, which is 4y, and then we will remain with y minus 1 is equal to 0. So that means y is equal to 0, or y is equal to positive 1. Now we have found the values of y. Now we need to calculate the values of x as well. We can substitute these values of y in equation number 3. So now where there is y, we are going to put 0 first. If I put 0 where there is y, I am going to get x is equal to 6 or where there is y, I can just put 1. If I put 1 where there is y, I am going to get x is equal to 2. So I have solved for x and y simultaneously. So we have x is equal to 6, x is equal to 2, y is equal to 0, and y is equal to negative 1. So let me move to 1.4. We are given the solution of the quadratic equation. So here is the solution here. The first question, we are required to state the values of p for which the equation will have 2 equal solutions. If they say solutions are equal, that means we have 2 equal roots. So if roots are equal, that means the discriminant, whatever that is under the square root, is equal to 0. So in this case, under the square root, we have 2p minus 5 is equal to what? Is equal to 0. So p, or it is 2p plus 5 is equal to 0. So p is equal to negative 5 over 2. So, and then for non-real, which is 1.4.2, so for no solution or non-real, discriminant must be less than 0. So that means your p will be less than minus 5 over 2. And then we are done with this question. Please do not forget to comment